Electrochemistry is a branch of chemistry that studies the relationship. It's a branch of chemistry that studies the relationship between chemical reactions and electricity. Electrochemical process takes place in a cell, and this cell is known as electrochemical cell, and this cell is known as electrochemical cell. So I said electrochemistry is a branch of chemistry that studies the relationship between chemical reactions and electricity. And now I just gave us a simple example. I said your battery, any type of battery you could think of, right? The process in which those battery produces electricity, right, is a chemical reaction taking place inside the cell. And that type of cell is called electrochemical cell. Not just any type of cell, electrochemical cell. All right, I was saying that we have different types of cell. We have cell in biology, which we know as the basic unit of life. So the cell in biology is different from the cell in chemistry. The cell in chemistry is referred to as electrochemical cell. We want to look at the types of electrochemical cells that we have. Now, because we have two types of electrochemical cell, the first type is a case whereby the battery produces electric current due to the reactions taking place inside the battery. And the second type is the battery, undergoing chemical reaction due to electric current. So when you're charging your battery, right, you're causing a reaction to take place inside the cell. All right, when you stop charging your battery, the reaction will now start taking place inside the cell to produce electric current. So it's more like a vice versa. Your phone battery functions this way. If you're not charging it, your phone battery powers your phone. If you're charging it, your electricity powers the battery. So let's look at the types of electrochemical cells that we have. Please put down types of electrochemical cells. Now, please put down, we have two major types of electrochemical cell. Two major types of electrochemical cell, namely, the first one is called galvanic, and the second guy is called please take note that both of them, they mean one and the same thing. So just in case you're asked, the two types of electrochemical cell is not this and this. It's any one of this and this guy. Galvanic is same thing as voltaic cell. All right, so I'm going to explain each of them one after the other. Please, I believe you've taken note of, these are the topics we are going to be doing today. I've done the introductory parts, all right? I've told us what electrochemistry is all about. We've discussed electrochemical cell. Basically, we have two types, this and this. So we now want to break this down. Class, let me tell us something. In electrochemical cell, we said it's a container or a tools whereby chemical reactions take place inside the cell to produce electric current or vice versa. Now, every electrochemical cell have what we call electrodes. We have two electrodes. You don't have to write, just listen. We have the cathode and we have the anode. The reaction that takes place at the anode is a half reaction because a full cell comprises of cathode and anode. So if I divide something that contains cathode and anode, I will now have 1, 1. So the reaction that takes place at one of the electrodes is called half reaction. The one that takes place in another part is called half reaction. When I combine both of them together, I now have a full cell reaction. Oxidation takes place at the anode. Reduction takes place at the cathode. Right? And anode and cathode mix up to form a cell. So when you combine those two reactions together, we have redox reaction. All right? So that's why I had to place half reaction before redox. But let's first of all understand the difference between the first one and the second guy. Please put down galvanic and voltaic cell. Please put down. This is a type of electrochemical cell. This is a type of electrochemical cell in which spontaneous chemical reactions inside the cell result in the production of electrical energy. It's a type of electrochemical cell in which spontaneous chemical reactions inside the cell result in the production of electrical energy. Now, when something is spontaneous, class, it simply means the stuff has the tendency to occur on its own without the aid of an external force. Example of a spontaneous process is that grass normally will always grow. If you pour water, water will flow down a hill. If you want to take water up, you use a pumping machine. That is why most of our houses, we have overhead tank. At the time where you want to pump the water from the ground to the tank, you on your sumo. The sumo pumps it. But when the water wants to come from your tank inside your house, it does not need any sumo because that process is spontaneous. Normally, it falls down. So any process that has a tendency to occur on its own is a spontaneous process. So this type of reaction, a spontaneous chemical reaction inside the cell, will give rise to electrical energy. So take note of this word spontaneous. That is the deciding factor or what makes the major difference between this guy and electrolytic cell. In galvanic cell, spontaneous reaction, it stays on its own and starts reacting and produces power. However, in the case of electrolytic cell, the reverse is the case. You put energy inside the cell to force a reaction to take place. So just in case you're asked, what's the difference between galvanic cell and electrolytic cell? Now the difference is that in galvanic cell, reaction inside the cell occurs spontaneously on its own. And that process leads to production of electrical energy. Whereas in electrolytic cell, energy or electricity is put inside the cell to force a reaction to take place. Take note of that. All right. Please put down notes. In galvanic cell, cathode is positive and anode is negative. In galvanic cell, cathode is positive while anode is negative. Now let's talk about electrolytic cell. Now based on what I just told us now, you can actually make out something for this guy. But let me just define it. Please put down. Electrolytic cell is a type of electrochemical cell in which electrical energy is a type of electrochemical cell in which electrical energy causes reaction to take place inside the cell. It's a type of electrochemical cell in which electrical energy causes a reaction to take place inside the cell. Full stop. Class, notes. In terms of, listen, the major difference between two of them is in their mode of operation and in their terminals. Remember I told us that every electrochemical cell, be it galvanic or electrolytic cell, has two electrodes. But I'll give us that to write it down. It has two electrodes, cathode and anode. Now the only difference between them is that in the case of galvanic cell, cathode is what? I told us cathode is what? Positive. Anode is what? Electrolytic cell is the reverse of it. So please put down, in electrolytic cell, cathode is negative and anode is positive. In electrolytic cell, cathode is negative and anode is positive. Full stop. Please put down paragraph. Generally, electrochemical cell possesses two electrodes. Generally, electrochemical cell possesses two electrodes. Generally, electrochemical cell consists of two or comprised of two electrodes, the anode and the cathode. So be it galvanic, be it electrolytic cell, they possess these two electrodes. So the only difference is their terminals. In electrolytic cell, cathode is negative, anode is positive. Whereas in galvanic cell, vice versa. All right. So let's look at the next topic here: half cell reactions. Half cell reactions. So why is this particular topic important? Because every cell, for a cell to be called a full cell, it must contain two electrodes, the cathode and the anode. And each of them, reactions occurs on each of them. Reaction that occurs on the anode is oxidation. The one that occurs on the cathode is reduction. All right. So what if we now consider each of them individually? Cathode and anode come together to form a full cell. Cathode alone makes half cell, anode makes half cell. Until you combine them, that's when you get full cell. So the reaction that takes place at each of those electrodes are what we refer to as half cell reactions. So let's look at, please put down, there are two fundamental types of half cell reactions. Two fundamental types of half cell reaction. Number one, oxidation. Number one, oxidation. You can make it in a tabular form so that I'll just give us the definition of oxidation. And number two, reduction. Now let's look at the key features or definitions of oxidation. Now each of them, we can define this guy in four different ways. The first one we have gain of oxygen. The second guy we have loss or removal of hydrogen. Number three we have loss of electrons. Number four we have increase in oxidation number. Now, so this gain is same thing as saying addition. So it's more like gain of oxygen or addition of. So anytime oxygen is being added to a substance, that's basically oxidation. So in this case, we have removal or loss of oxygen, gain or addition of hydrogen, gain of electrons, decrease in oxidation number. So these are basically the definitions or how we can define oxidation and reduction. So we have now, but not all of them is actually needed here. Two is not needed in this particular. We need this, but it's not that effective. In organic chemistry, we're going to be focusing more on addition of oxygen, removal of hydrogen, and the rest of them. So the first two definition is more effective when we talk about organic chemistry, because organic chemistry have more of oxygen and hydrogen. But in the case of inorganic chemistry or general chemistry, we're going to be dealing with loss of electrons and increase in oxidation number. All right. So the reason why I actually give us this, because from now, after now, I'm moving to oxidation numbers. So after now, we're moving straight to oxidation number, because we cannot really understand increase in oxidation number or this if we don't understand how to solve for oxidation number, because Now, this is just half cell reaction. When you combine in a cell, a full cell comprises of cathode and anode, right? Now, oxidation is actually the one that takes place at the anode, and reduction is the one that takes place at the cathode, irrespective of whether it is galvanic or electrolytic cell. Now, so since we've seen the definition of this guy, and how are we going to make use of it? Fine, we're going to use this guy in balancing redox reaction, because it might give you redox reaction in acid medium or in basic medium, and you're asked to balance. For you to be able to balance redox reaction, you need to split it into half cells. If you could remember, maybe for those persons that could remember, we have different ways to balance chemical equation. We have inspection method, we have algebraic method, and we have half reaction method, right? Half reaction is mostly used for redox reaction. So once they give you a reaction, you split it into two parts, reduction and what? And then balance them individually. So let's look at rules for oxidation number. Rules for assigning, it's supposed to be rules for assigning oxidation number. Because we need to understand oxidation number if we must balance redox reaction very well. Number one, the oxidation number of an element in its free form or uncombined form is 0. Oxidation number of an element in its free form or uncombined form is 0. That's rule number one. Number two, oxidation number of a monoatomic ion is the charge on the ion. Oxidation number of a monoatomic ion is the charge on the ion. Now this is what I mean. The first one was, I said, element in an uncombined form. You see something like this: sodium standing alone, chlorine. Oxidation number of this guy is 0 because this guy is not combining with any other elements. Now the second guy, we said something like this. These elements, these are monoatomic ions. They just have one atom, and they are ions because they have a charge. We also have something like this. So we said the oxidation number of a monoatomic ion are the charge on the ion. So this guy has oxidation number of +1, +3, and -1. Number 3 says oxidation number of elements in group 1 and group 2 of the periodic table are +1 and +2 respectively. Oxidation number of elements in group 1 and 2 of the periodic table are +1 and +2 respectively. That means if you see something like Na2SO4, now look up. Now in this case, now sodium is actually not uncombined, but sodium is actually inside a compound or inside a molecule. So if you want to get the oxidation number of sodium in this compound or in this molecule, sodium is in group 1, and group 1 elements will have +1, right? Because I said elements in group 1 and group 2 will have +1 and +2 respectively, right? Sodium being in group 1, here will be +1, right? So in cases like this, they will specify which of the elements you're to solve for the oxidation number, or the one you're to look for. Okay? So number 4, we said oxidation number of hydrogen is always +1 except in hydride. That is when it combines with a metal. Oxidation number of hydrogen is always +1 except in hydride. Except in hydride. That's when it combines with a metal. Okay, so I don't even forget now one talk, sir. You guys having AB practicals? Well, I'll see you in the class by 3 o'clock, sir. I said oxidation number of hydrogen is always +1, except in hydride where it is -1. Except in hydride where it is -1. Except in hydride where it is -1. Obviously, what are hydrides? Whenever you have something like this, lithium, aluminum hydride. Now this is hydrogen combining with metals. This lithium is a metal, aluminum is a metal. So in this case now, aluminum hydrogen will now have -1. But if you have hydrogen, it's not battery, I know. This fake phone, why they manage? Don't worry, let me just manage it for today. So if it is in a case of, let's say, H2SO4, this guy, this is a non-metal, this is a non-metal, so hydrogen will be +1. So hydrogen can only take -1 when it combines with a metal. Take note of that. Yeah. Number 5, oxidation number of oxygen is always -2, except in peroxides where it is -1. Number 6, oxidation number of group 7 elements in a binary compound is always -1. Oxidation number of group 7 elements in a binary compound is always -1. Oxidation number of group 7 elements in a binary compound is always -1. Now, what do I mean by binary compound? And what are group 7 elements here? Chlorine, chlorine, bromine. Now, group 7 elements are the halogens. So anytime you see these guys, binary simply means 2. If I have something like this, HClO4, how many elements do we have in this compound? Is this a binary compound? In this case, this chlorine now, oxidation number of chlorine cannot be -1. So in this case, they will ask you to solve for this guy. If you have, this is hydrogen tetrahydrochlorate 7, this chlorate 7. But if you see something like HCl, this is a binary compound. What if I have SF4? This is a binary compound. It is a binary compound because I was looking. You don't look at this. These are the atoms, right? We have 5 atoms here: 4 chlorine, 1 sodium, 1 sulfur. But the element is how many? 2. Just sulfur and what? So in this case, fluorine will have -1. So oxidation number of group 7 elements is always -1 whenever they are present in a binary compound. But if the compound is not binary, the oxidation number cannot be -1. And as a matter of fact, that is what they will ask you to solve for. Right? So let's look at the next one. The sum of oxidation number of all atoms in a neutral compound is equal to 0. The sum of oxidation number of all the atoms in a neutral compound is equal to 0. The sum of oxidation number in a neutral compound is equal to 0. Now this is what I mean. If I have something like, let's say, HClO4, and then, for example, I'm asked to find the oxidation number of chlorine. I do not know what chlorine is, so I'll make it X. But hydrogen, I know hydrogen is always +1. Chlorine, I do not know. I know chlorine to be -1 when it is in a binary compound, right? But this guy is not binary, so I'll make it X. Oxygen is always -2, except in peroxide, and this is not peroxide. So I'll say times 4. Now this will be equal to 0 because this guy is a neutral compound. So this rule number 6 is what I just did now. The sum of oxidation number of all atoms in a neutral compound is equal to 0. This compound is neutral because there is neither positive nor what. But what if I had some? Okay, let's look at the next one, the last but not the least, number 8. The sum of the oxidation number in a polyatomic ion is equal to the charge of the ion. The sum of the oxidation number in a polyatomic ion is equal to the charge of the ion. Like let's say MnO4 minus. and I'm asked, I do not know this guy, but whatever the value of this guy is, if I add it to that of oxygen, it must give me equals to -1. I always equate it to -1. So let's assume I do not know manganese, and I'm asked to solve for manganese. Here becomes X plus oxygen is -2 times what? Equals to minus what? 1. So for a polyatomic ion, you equate it to the charge. So let's see some few questions. Please put down. Calculate the oxidation number of A S in H2SO4, B Mn in KMnO4, C So we have these 3 examples. All right, so let's solve this guy. Please look up. Solve for. So in this case now, I'll say A. If I want to solve for sulfur, anywhere I see sulfur here, I'll call it X. Hydrogen, I already know, is always going to be +1. Oxygen is going to be -2. So this is going to be S in H2SO4. This is going to be, hydrogen is +1 times 2 here, plus sulfur is X, I do not know, plus oxygen is -2 times 4. Do not forget that at the end of the day, we are going to equate it to 0 or charge, depending on whether this guy is neutral. So if you look at this guy, this is neutral, right? So equate it to what? 0. Plus 1 times 2 is 2, plus X minus 8 equals to 0. -8 minus 2 times 3 is -8. So X now becomes equals to, if this guy comes over here, becomes 8 minus 2 equals to +6. So for the B part, manganese in, please, you really know how to solve for this guy. Now what is the application, or why do we need this? Because in oxidation in redox reaction, reduction or oxidation reaction is being carried out simultaneously. So you need to know what is oxidizing and what is reducing. If sulfur at the left hand side of a reaction was 4, and then at the right hand side of the reaction you solve for that same sulfur again and you're seeing 6, it means that sulfur has moved from +4 to what? +6. There is an increase in oxidation number, is it not so? That means oxidation has taken place. But if sulfur was initially +6 on the reactant side, and on the product side you're seeing +3, there is a reduction in the oxidation number, right? And that's what? Reduction. So that's the advantage of this. Now, potassium is in group 1 of the periodic table. And I told us every element in group 1 have +1. Every element in group 2 have what? +2. So this guy will be +1 plus manganese is what we are looking for. We call it what? X. Plus oxygen is -2 times what? 4. This is going to be equals to what? 0. Please, let me remove this guy so that, please, you can do this. I want this one to be charged. Remove that hydrogen and put minus there. So equate it to 0 because this guy is neutral. So this is 1 plus X minus 8 equals to 0. X equals to 8 minus 1 equals to +7. Please, a sign is very, very important. If it is plus, you must put the plus. If it is minus, you must put the minus. If you don't put any of those signs, you have yourself to blame. 7 and +7 is not the same. 7 plus 7 is, once you see +7, we are referring to oxidation number. Or another name for oxidation number is valency. Is what? Take note of that. Valency, not valence electron. So let's solve for the last guy. Then we'll look at redox reaction. So for the C part, we have C in Cl O4-. Now this is a polyatomic ion. Polyatomic simply means it contains more than one atom. This guy has 5 atoms. 4 oxygen, 1 chlorine. So this is a polyatomic ion. So we'll say, I do not know what chlorine is, so I'll make it to be X plus oxygen is -2 times 4 equals to -1. You equate it to the charge of the compound. you sum this guy and you equate it to the charge. This is x minus 2 times 2 is minus 8 equals to minus 1. X becomes minus 1 plus 8, which is equal to what? Plus 7. Not 7. Plus 7. Not 7. Now, another thing I would like us to understand here is knowing what we refer to as oxidizing. I don't want to miss any part. Now, because they can give you a reaction and they say, which of these is an oxidizing agent and which of these is a reducing agent? Now, let me give you something like this. Let's say, example, we have zinc plus 2 HCl, giving us zinc 2 plus 2Cl minus plus H2. Class, look at this reaction here. I want to explain oxidizing agents and reducing agent while also seeing how I can explain oxidation number. Now, oxidation number of this zinc, remember first rule, element in an uncombined form or free state is 0, right? Oxidation number of zinc is what? Hydrogen here. Hydrogen here is going to be plus 1 because this is hydrogen combining with a non-metal. Chlorine here is going to be what? Because this is a binary compound. Is it not so? Zinc here, this is now an ion. Oxidation number of a monoatomic ion is a charge. So this is going to be what? Plus 2. Chlorine is going to be what? And hydrogen is going to be what? 0, because this is uncombined. Remember I say even if it's combining with itself, as long as it's not combining with any other element, it's 0. So now let's look at zinc from 0. Is that increase in oxidation number or decrease? So increase in oxidation number is what? Oxidation. It moved from 0 and it's now what? Plus 2. Now chlorine moved from minus 1 to minus 1. Nothing has changed. Chlorine did not undergo reduction. It did not undergo oxidation, right? But hydrogen here was what? Plus 1. And hydrogen here is now how many? There is a reduction or a decrease in oxidation number. Is it not so? So this guy, I don't know how to put that. So let me just use the up part. So this becomes reduction because there is a decrease in oxidation number. Now, if you're asked to tell what is oxidizing agent and what is reducing agent, class, this is a concept you're going to make use of. Anytime they say agent, if they say house agent, the agent is not the one living in their house. Is it not so? It's helping somebody get their house, right? So if I say oxidizing agent, what I'm referring to is not the one oxidizing, it's the agent of oxidation. So oxidizing agent is what helps the other person to do what? Oxidize. Reducing agent is what helps the other person to do what? So oxidizing agent himself will actually carry out the opposite of its name. What is the opposite of oxidizing? Reducing, right? So oxidizing agent himself will be reducing, right? Now look at this. Zinc oxidized from 0 to plus 2, right? This compound was what helped this guy to oxidize. In this compound, hydrogen reduced from plus 1 to what? 0. This was what helped this guy to reduce. It cannot occur on its own, right? So in this case now, I'll say oxidizing agent is substance undergoing reduction, whereas reducing agent is substance undergoing oxidation. Now let me explain this further. Another point. Now, if you notice, it's not this entire compound. It was just hydrogen that reduced here, right? If you want to classify this guy as an agent, you're not just going to come and pick out hydrogen. It is this entire stuff here because hydrogen is not standing alone. Hydrogen is standing with this chlorine, right? So in this compound, it is hydrogen that reduced, not chlorine, right? So I'm not going to say, okay, the agent oxidizing or reducing agent is just hydrogen. You're not going to do that. So in case you want to follow this stuff now, you now come and say substance undergoing reduction, right? Zinc, hydrogen is the one undergoing reduction, is it not so? You now come and say, so therefore, hydrogen is the oxidizing agent. You're not going to do that. Hydrogen, the compound that will contain that hydrogen itself is what you're going to refer to as that agent. Do you understand what I'm saying? Yes. Okay, so let's look at this guy. Oxidizing agent itself undergoes reduction. That, for me, the moment I found out this, I didn't even cram it. Oxidizing agent himself undergoes what? Reducing agent himself undergoes what? So once you have a reaction and they say identify the oxidizing agent, don't stress. Once you have something like this, zinc, so I'll say look up, zinc is undergoing oxidation, right? From 0 to what? So zinc is the what? Good. Now because zinc is standing alone, you come to this guy, hydrogen moved from +1 to 0. So hydrogen is reducing, is it not so? So, but this hydrogen is not standing alone. It's inside a compound. Substance that is reducing itself will be oxidizing agent, is it not so? But I'm not just going to say hydrogen here because hydrogen is present with what? So I'll now say HCl is what? So that is how we actually identify oxidizing and reducing agents. Please note this. In redox reaction, the two processes takes place simultaneously. Oxidation and what? Reduction takes place as one is oxidizing, the other one is reducing. That's why we call it redox reaction. All right, so for us to balance redox reaction, we're going to be using half reaction method. They give you a reaction, you're going to use the oxidation number and determine the one that is oxidizing and determine the one that is reducing. Once you've done that, you split them into two half cells. Get your reduction half cell and get your oxidation half cell, and then you proceed. However, the medium is always different. They can either tell you to balance that in an acid medium or in a what? Basic medium. Please put down. Redox reaction can take place in either of the two medium listed below. Redox reaction can take place in either of the two mediums listed below. Number 1, acidic medium. Number 2, basic medium. Whether it is acid medium or basic medium, first thing first, you must split it into two half cells. Right? You must now, once you've done splitting it, you can now, the difference between acidic medium is just when you're balancing hydrogen and oxygen. Right? So the process of all of this, I've already recorded a video. So let me actually show us how to split a particular question. So please put down, balance the following redox reaction like I said, I'm not going to be going into details of the acidic medium rules and steps for today. Right, for today. So once I'm done, I'll compile this video and then merge it up with the old one, so you can watch it until our next class can even understand how to do this.